Welcome everyone, this is the first lesson recording for IM2, February 25th, 2021. We started off by watching a little video from Journey to the Center of the Earth. Watch the Glowstick and see how they are using math to figure out the depth of the cliff. Great, so this is application of quadratic equation there, right there. So we are going to be exploring this in a little bit. So what are we doing today? We are going to be looking at quadratic solving techniques in action and more complex case of solving using square rooting, and then introduce the third method. Alright, to begin you're going to be working on some falling glow stick Desmos activity. The first card gets you to watch the video again, and then you write down what you notice and what do you wonder. The second card asks you to simulate a different pit. Dahlia is at another deep pit. When she throws a glow stick, it took 5.6 seconds to land. Drag the 5 points and place them where you think the glow stick is at 1 second after release, 2 seconds after release, and so on. Okay, so my initial thought will be, okay, so it took 5.6 seconds. Maybe if I divide it up, so after 1 second, I'm just going to divide that depth into 5 different sections, maybe 5.5 sections. 1, 2, 3, 4, 5, something like this. The last one is little bit shorter in distance because it's only part of a second. So that's my initial guess. Alright, and then click the arrow to show the actual location in the 5.6 seconds. Okay, so that the points are at a very different places, aren't they? Okay, how do your prediction compare? I was pretty off. What do you wonder about the actual location? Look at the locations. It seems like it doesn't go very far the first second, and then second, the distance it travels seems to be increasing each second. Alright, then now the glow stick depth measurements are shown on the left. Translate the information onto the time versus depth graph below. Okay, so at 1 second it had gone down 16 feet, so I am going to move this 16 feet. The 16 feet, maybe it'll be about here. Then 2 seconds, 144. 3 seconds, 256. So between 200 and 300. And 400, oops, 4 seconds will be 200. Okay. Alright, so now I made a mistake here. Okay, so 2 seconds is 64, so 64 would be about maybe here. 3 seconds would be 144, would be about here. And then 5 seconds would be about 400, right there. That's what my graph would look like. Look at the shape. Does it look like a straight line? No, it's not, is it? Okay, it is actually a parabola. It's a half of a parabola here. Alright, then press the arrow to see the time versus depth graph in the action as the glow stick reveals. And look at that, that is a parabola. Okay. Alright, so now which of the following equation would represent the glow stick step D as a function of time t? Well, what do you expect? You expect, since this is a parabola that is opening down, you would expect this to be have the negative leading coefficient. The number in front of the squared term, the squared variable, will be negative. So that rules out the second possibility. So we're just left with first, third, or fourth. Okay, what else do we know? When t is equal to 0, what was distance? It was also equal to 0. When t is equal to 0, what was the distance? It was also equal to 0. So this will certainly work. Okay, the other ones, when t is equal to 0, this will be a linear equation. That's certainly not a straight line. What about this? This is actually an exponential graph. So it is this one. And explain in your thinking. Alright, then using Sean's rough count of 3 seconds, help Trevor Anderson estimate how deep their pit is using d is equal to negative 16t squared. That is actually going to be the equation that you can use for anything that you drop. Okay, so that is going to be consistent because the gravity is pretty consistent. So d is equal to half 16t squared, and he said approximately 3 seconds. So it's going to be 3 squared times negative 16. So it is, distance is going to be equal to, okay, negative 16 multiplied by 3 squared, which is 9. And that's going to be negative 144. So we're expecting the depth of the pit to be about 144 feet. Okay, let's see what the movie actually said. And see if you can be the critic here. Okay, so what do you think? They were wrong, yay! We know better. It was closer to 144 feet, not 200. Well, that is a math for you. Okay, now let's do another application problem. How many seconds for the rock to reach the bottom of a 256 feet valley? What do you think? We can use this d is equal to negative 16t squared, because this is really same as d is equal to half g, that's the acceleration due to gravity, multiplied by t squared. So when we use this, you're told that the total depth is 256 feet. That means 256 is equal to negative 16t squared. So what do we do now? We need to divide both sides by negative 16 first. In fact, this is actually negative 256 because we're talking about the distance going down. Okay, so that we are dividing both sides by negative 16, and that cancels out. 256 divided by 16 is actually 16, is equal to t squared. So now we're going to take a square root of both sides, and when we do that, remember we need to put plus or minus sign on the side with just the number. Okay, so and then square and square rooting, they cancel each other out, so you're left with t is equal to plus or minus square root of 16 is 4. So that means it will be either 4 seconds or negative 4 seconds, and negative 4 seconds does not make any sense in this application, for that it takes positive 4 seconds, and that will be my final answer. Now you're going to answer in private chat for me. Name the 2 quadratic equations solving techniques that you've learned so far. Okay, so in this unit we started by using 2 different solving techniques. What were they? Can you name them in private chat? They were the zero product property and solving by taking a square root. Okay, now the second question is, for the zero product property method, describe the highlight of the method. Well, what was the highlight? Well, what we did was we tried to factor the quadratic equation, And if it was factorable, then we could set each of the factor to be equal to 0, and that's how we solved. What about the square rooting? Okay, describe the highlights of this method. Well, this was used when you have some variable being squared that is equal to just a constant number. So you do not have the middle x term. Okay, so you only have the squared x squared term and just a number. In that case, you can use this method to take the square root of both sides and figure this out. And so the second method is actually pretty easy if it fits that criteria. So if you're given this equation, what would you do? 2 times x minus 1 all squared minus 8 is equal to negative 2. Alright? Well, you can use both the methods. And let's see what that will look like. To use the zero product property, what we had to do was we had to set the quadratic equation to be equal to 0. Okay, so that means we actually had to put the quadratic equation in standard form, that is equal to 0, and then factor it. So we have 2x minus 1 all squared minus 8 is equal to negative 2. So what we needed to do was we actually had to expand this, as well as you need to bring all the constants to the left hand side. So let's start by expanding this and so that we can put this into standard form. I can bring the negative 2 to the other side of the equals by taking the negative of this. Negative of negative 2 is positive 2, so I'm going to bring this to the other side by plus 2 is equal to, now the right hand side is equal to 0. Now let's expand this by using FOIL. I am going to leave my 2 here. X times x is x squared minus x is going to be negative 2x. Negative 1 times negative 1 is positive 1. Minus negative 8 plus 2 is negative 6 is equal to 0. That's what I have. Now I'm going to distribute 2 to each of the terms inside. That leaves me with 2x squared minus 4x plus 2 minus 6 is equal to 0. Then I add the like terms, 2 and negative 6, that becomes 2x squared minus 4x minus 4 is equal to 0. Okay, now I need to try to factor this. Okay, if I try to factor it as it is, the leading coefficient is greater than 1. That means I need to go into my diamond and use grouping method or area model. But I see that they all have the common factor of 2, or they're all even. That means I can take out the 2 and you're left with x squared minus 2x minus 2 is equal to 0. Now this is a lot more easier to factor, much easier to factor. So that becomes 2x and x. What two numbers multiply to negative 2 that add to negative 2? Is that possible? Is that possible? Is there two numbers? The only factor of negative 2 is positive 1 and negative 1. So if I have positive 1 and negative 2, or negative 2, positive 2 and negative 1. But either way, I am not going to get negative 2 as my sum. So it is not factorable. As well as this is quite a long process in this case. Is there a better way? And we're going to use that. So how do I do this? That's 2x minus 1 all squared minus 8 is equal to negative 2. I am going to bring the negative 8 to the other side by adding 6. So that becomes 2x minus 1 all squared is equal to, add 8 to both sides, that becomes positive 6. Divide both sides by 2. And you get x minus 1 all squared is equal to 3. So from then on, I take a square root of both sides with a plus or minus on the right hand side, and I get two different solutions, and then you split that up and you get your final